Historically, designing, testing, and fielding a new weapon system took decades. Entire careers were spent navigating bureaucratic approvals to get a single missile variant from a blueprint to a factory floor. On the battlefields of Ukraine in 2026, that timeline has collapsed. A piece of technology that dominates an engagement on Monday can be completely ineffective by Friday. This environment has forged the adaptation spiral. It is a relentless, accelerating cycle of strike and counterstrike, driven entirely by the immediate need to survive. To survive this loop, Ukrainian engineers cannot simply react to what the enemy is doing today. They have to anticipate and invent the countermeasure to a weapon the enemy hasn't even deployed yet. This cycle of innovation has compressed the traditional evolution of military hardware, turning what used to be decades of development into a single combat season. Early on, Ukrainian forces leveled the playing field against superior Russian armor by strapping explosives to commercial, GPS-guided drones like the Vampire hexacopter. Russian forces countered rapidly. They blanketed the front lines with advanced electronic warfare systems, using intense signal jamming and GPS spoofing to sever the radio connections between the drones and their pilots. In response to the jamming, Ukrainian units deployed drones trailing miles of physical fiber optic cable, making them completely immune to radio interference. They also integrated AI computer vision that locks onto a target and navigates autonomously, even if the pilot loses the video feed. The intense pressure of the electromagnetic contest is forcing the development of weapons that bypass human control altogether. The adaptation loop is just as aggressive in the sky. Russian forces scaled their attacks, launching swarms of up to 500 Shahed drones at once. As seen from this Geran 2 debris, these models were upgraded with jet engines to fly faster and higher, evading basic ground-based fire. Firing a $1 million traditional interceptor missile at a $20,000 drone is an economic dead end. When a swarm numbers in the hundreds, traditional anti-aircraft batteries simply run out of ammunition. Ukraine solved this volume problem by creating the transparent battlefield. They linked varied aerospace assets, from ground sensors to fighter jets, into a single digital hive mind. An early warning plane detects an incoming drone swarm from far away. It feeds those exact real-time coordinates directly to airborne F-16 fighters via a secure data link. The pilots intercept the drones without turning on their own radars, remaining invisible to enemy surface-to-air missiles. Surviving mass saturation attacks requires abandoning the concept of the lone interceptor. Defense is now an exercise in total, integrated network management. One critical vulnerability threatened Ukraine's entire adaptation loop: an absolute reliance on Western political permission to use long-range precision weapons against deep logistical targets. To solve this, the Ukrainian Ministry of Defense executed a massive institutional overhaul. They centralized all military supply and procurement under a single digitized system called dot-chain, stripping away bureaucratic bottlenecks. This efficiency allowed the domestic military-industrial complex to scale its production capacity from $1 billion at the start of the war to $30 billion by 2026. The kinetic result of that industrial surge is visible in hardware like this mobile launcher platform. Ukraine began serial production of its own deep strike weapons, including the 1,000-kilometer Flamingo cruise missile and the Mach 5 Sopson ballistic missile. By building their own missiles, Ukraine bypassed the political restrictions attached to foreign munitions, turning domestic production into a tool of strategic deterrence. By late 2025, the demands of the adaptation spiral forced military planners to reclassify warfare domains. Command staffs began treating data, software, and code with the exact same strategic weight as infantry battalions and artillery shells. This led to the formal establishment of Ukraine's independent cyber and space forces. They structured proactive network defense and the integration of commercial satellite constellations into official military branches. Economically, the country shifted from absorbing foreign technology to preparing to export its own. Utilizing the Danish model of defense financing, foreign partners began channeling funds directly into Ukrainian weapons contracts. The traditional flow of military expertise has reversed. As seen with allied defense ministers convening at the Ramstein meetings, Western partners are actively analyzing Ukrainian combat data to modernize their own defense bases. The battlefields of 2026 show that legacy stockpiles lose their value the moment an enemy adapts. Success depends on the infrastructure required to iterate faster than the adversary. Victory rests with the nation building a unified ecosystem where code, industry, and the frontline operate as a single accelerating loop.